Well, good morning, and it'll be good afternoon when it airs this afternoon at 4.
Well, good morning, Dr. Campbell.
Good morning, Miss Young. And I want to say hi to all the boys and girls 6th grade. If you're up yet, which I'm going to say probably not, you can watch at 4 this afternoon.
And good morning, 5th graders at Discovery School. Good to see you today.
You know, got some. I have something that I don't allow in my classroom.
Yeah, just.
But I have it for today because it has something to do with what we're doing today. But before we get started, you want to talk about the Smile Challenge?
Let's talk about the Smile Challenge.
Okay, so guys out there, this is a partnership with TDOE and TSIN, and they have a parent hub that puts out, and if you'll notice on our Facebook page too, we have activities, or they have activities they share with us so that we can get into science at home and really think about engineering. So if you don't mind, if you could go to our Facebook page that's already been posted, there's a Maker Monday, a Wonder Wednesday, and what's Friday? Future Friday. That's right. Just had to have an assistant help me with that. And it's important for us to make sure that we are thinking science and math all the time, and it's really cool stuff. But you know, I noticed last week it was a Smile Challenge.
I love that.
Smile Challenge. And you know, the thing we're doing today kind of makes me smile too.
Oh, yes.
I know. And so if you guys want to, the Smile Challenge is really awesome. Anything you have at home, anything that you can make. If you want to check out the YouTube video, the Smile Challenge, there's a little girl that talks about using whatever you have at home. It is so good. And we'll post that video later on the Facebook stream. So if you want to go there, that'll be there. But she actually makes a face and a little heart with some Legos and some different things, and she shows it to her parents, like outside the window, just to make somebody smile. So anything that you have at home that you can create, and the engineering process, if we want to go ahead and put that up, we'll look at that just for a moment. The engineering process is, what's the question? The question is, you know, we want to make people smile, Miss Young. You know, we want people in this time of unknown, in this time of newness, right? We want to continue to think about problems that we can solve. You know, there's all kinds of people putting together, they're thinking in that way. And so we have the engineering process. So you're going to ask a question. The question is, can we make somebody smile? Right?
Yeah.
And we're going to do that in a little bit.
We are.
We're going to do that in a little bit. And then you're going to brainstorm how you're going to make somebody smile. You're going to have a plan. Create something, build or a solution. You might have to test it out on somebody to see if it makes them smile. You know, you should see if it makes them smile, and then you may have to improve it. But this is the engineering process, and it's really cool though. You can use the engineering process for everything. Almost everything. So it's really awesome. We'll go on to the Smile Challenge slide next. The futureengineers.org/start a smile. It'll give you a place that you can go on and start your Smile Challenge. Okay, so you know, we probably need to get into what we're doing today. So if we whatever we're chewing, we might want to take a peek.
Yeah, take a peek.
Take a peek. What we might need to put on our lab coats.
Put on our lab coats.
Let's put on our lab coats. Okay. Before we start that science, really getting deep into it, we're gonna put on our lab coats. Get ready to go.
Like protective gear.
Yep, got to. And we don't want anything to get on our clothes.
No.
And to do some of these things, guys, out there, to do some of these things, you're going to probably want maybe to go outside later. And then Miss Young has her protective eyewear as well, just making sure we don't get anything in our eyes.
Yeah.
Safety first.
Safety first.
That's right.
Exactly.
Okay, so I guess you guys thought we were being really rude, and we talked about having chewing gum, right?
Yeah.
But what? I don't know what we're going to... What do we do with that chewing gum?
We could really make somebody smile if we
did something make somebody smile.
Yes. Let's try it.
Oh, yep, blowing bubbles. And you know that I haven't done this gum. I haven't chewed this bubble gum in such a long time, so that's made me smile this morning. Well, we're going to talk about a phenomena today, a phenomena that we are going to explore. It's something like we just blew. Bubbles. And you can't miss it because it's on our title of today's show. And we are going to look at different experiences with bubbles.
Yeah, we've got some experiments today, Dr.
We do, but we need to look at the definition of phenomena.
Yes, we do.
First, because we want to talk about what that really means. It's kind of a weird word.
It
What
is
do
a
you think,
weird-
Miss Young? What do you think about that?
Phenomenon. Oh, phenomenon.
Mm-hmm.
Wow.
And it's one of those weird words like cacti and cactus, right?
Yes.
Phenomena,
Yeah.
phenomenon, right?
Yes.
I know, we have to make sure which one's plural and which one's singular. Little English lesson today.
Little English lesson.
So, what's the definition? Can you read it for us?
Well, the definition is a fact or situation that exists, and the cause or explanation is in question.
Okay. So if it's a fact or situation, what's the situation today? Are we about to look at it?
I think
Are we
we're-
about to take a peek?
I think we're about to take a peek.
Okay, let's take a peek.
I have an experiment I'm going to show the boys and girls.
You do not.
I sure do.
Oh, I have one too.
Yeah, well, that's good.
Uh-huh.
I'm
I
glad.
didn't mean to.
Social distance.
I know, that's
okay.
right.
So, I've got my bag of tricks here.
I saw you
Like,
bringing a bag and all these goodies. I'm very interested. I'm very curious as to
Yes.
what you're going to do.
Well, if we could see the next slide about bubble experiment number 1.
Oh,
the boys and girls
yes.
and the audience can
And
see
ca-
what's going on.
In case they want to take a picture,
Yeah, take a picture of this. So all
and
you
they
need
can make it later.
exactly. So all you're going to need is a cup. It's a large cup, okay? So I just went to my kitchen and I found a large cup. And so then you're going to have
We need to see our items, don't we?
Oh, we probably do
yes.
need because it's really more fun.
Yes, and if they need to go back to the video, they can rewind it later. But we need to see what you're doing here at the table.
Yeah. So, boys and girls, all these items can be found at your house. Okay. I just have a cup here,
Yes, if we could put the recipe down there, it's excellent. Thank you.
yeah. And then we're going to have a cup and a half of water, which is in here. Then we're going to have a half a cup of the dish soap liquid, and then we're going to have some sugar. And I got to shout out to Sister Martha Ann because I didn't have any sugar at my house because it's really hard to find. But
Oh.
Martha Ann had
Speaker.
a bowl of sugar to let me borrow. So you just put like a half a teaspoon in there. So in the essence of saving time, I've already mixed up our mixture in my little bottle here, and I'm going to pour it into the cup.
Oh, this looks exciting. And this is why we said earlier you might want to go outside for this.
So, boys and girls, what you can do, you can just find items in your house, like this spatula. Or, I'm not sure what this is, Dr. Campbell, but I think it might be a strainer of an egg or something.
It's like separating an egg.
Separating
It's an egg separator, like so that you want to get the egg white
Right.
instead of the yolk.
And
I
then,
think.
And then this thing. I think it's like a melon. But
Oh,
you-
like you,
yeah,
melon
it's
baller.
Melon baller.
Did you
yeah.
just go through your drawers at home and find some things?
And then
oh,
I
you
have
had
these pipe cleaners.
Oh my goodness. Okay.
Make them into different shapes if you
Oh.
like. You know, I mean, make them into different.
And I think that's creative. Let's talk about what you're about to put these in there?
Yeah.
So what do you think's going to happen? Guys, what do you think's going to happen out there? I think you know, like they have these little containers that have those bubble wands.
Oh, I used to love that.
I know, and you
Yes.
know, it made me smile.
It made me smile.
But you have gotten all kinds of stuff out of the house.
Out
So
of the
since you're at the house, you guys can do the same thing. I love it.
So let me just try this. Little holes here.
Wait,
Now-
you said add sugar.
Yeah. Yeah. I
Can we
always
talk?
wondered
Can we
why-
talk about that for half a minute? I don't know. It's
Uh,
why would you add sugar? We're
I
not.
just have to do
We
something.
don't. We don't want to drink it. It's
No.
not healthy necessarily. It's
Don't drink it.
non-toxic. But we
Non-toxic.
don't want to drink it. But you added sugar.
It had.
So what do you guys think out there? Adding sugar to a bubble mixture? That's odd. Another phenomenon, I think. But
Yeah.
we're going to talk about
Okay.
that. So I wonder if we can't see what's happening inside that solution, and there's like tiny molecules inside that solution, and the sugar, I bet you the sugar helps those bubbles stick
Stick together.
together.
Stick together.
Sticky, like
like
okay.
sugar.
All right,
Let's try
that's
it.
amazing, and we can't see it; it's invisible. All right, let's try it. I'm sorry, you're ready. Let's go.
I have had so much fun.
I know. Let's go.
practicing this at home, boys
Let's
and
go.
girls.
Good.
So you can just like put it in here a little bit, and then you can a little bubble there. Make sure you have something to not.
Oh yeah, this is why we want to go outside. Oh, out of a spatula. Stop
Look
it.
at that, boys and girls. And this is my favorite. Just put it in here like this.
She told me how exciting this was. I can't wait. Oh my gosh, that's so
And
cool.
then the last one. This is a little one, but it's really fun. You just put it in here like this. Oh, it didn't really work.
Well, you got to keep trying. You know, sometimes failures help us.
Baby bubbles.
Baby bubbles.
Oh my gosh, Dr. Campbell, that was so fun and brought a smile to my face.
I love it. I love it. And you know what? I could see how you needed it with that because it might have just kind of got on your glasses. So I think it's great to,
Have the goggles.
have some goggles.
Yes.
I think it's excellent.
Oh my
So
gosh.
I think, what I'm really excited about, can I go ahead and do this?
Ooh, the calculator.
Just, I know, right? I want to go ahead and put this up, and you can see this from home. And she just created a solution. And this solution that has tiny molecules inside, we can't even see it. It just looks like liquid, right?
Just looks like liquid.
But there's some really cool things happening inside those bubbles as you make them. Really cool. And we'll talk a little bit more about that later, won't we?
Okay.
So we have a slide coming up that has a picture of a bubble and a balloon.
Oh.
So in order for us to really think through this phenomenon or the phenomenon of bubbles,
Yes. Okay.
I think it's important for us to ask that question out there. How are
A bubble and a balloon alike.
how are they alike? I think because we are familiar with bubbles and familiar with balloons, and they have something in common. So we're going to look at that. Okay? And now, guess what? I get to do my experiment now.
Yay,
I
Dr.
know.
Campbell.
So I'm going to have to move around the table,
Okay.
and we can turn that slide to that. Yes. I'm going to go ahead and let you see the recipe before I get to the other side of the table. And I want you guys to know it's not necessarily important for you to have exactly a cup of milk, but it works with a cup of milk, okay? A few drops of food coloring, a Q-tip, and some dish detergent. And so we have some common factors. So now we're going to look at, that's fine, just good. Now we're going to look at a different recipe with bubbles, and it's going to be very different than yours. So if we could go ahead and cue up the bowl. You might want to move over. Excellent. We probably want to do this, just so that we can see that bowl a little bit better. And your solution, I just think we're going to play with that later and have so much fun.
Yep, let's move it.
So if we can get as close to that bowl as possible and see that bowl, I'm going to put all of these things in at once. Now, Michelle, you had yours put together, and I love that, pre-made.
Right.
Because it makes sense, right? Well, this, you have to do it in front of everyone, okay?
I've got to tell you, I tried this at home, and it's so cool.
Oh, did you try this at home?
I did.
Oh my
I
gosh.
did.
It is, I played with this. Guys, I'm telling you, we are adults and have fun and had smiles with this phenomenon.
We did.
Okay, so it's great. So if you would just pour your milk inside a bowl,
Oh, wow.
okay? Now, milk is a little different than water. You use water, and I have milk, so it's a different consistency.
Yes, it is.
Right? And then the idea is to take some food coloring. Now, I'm going to tell you guys, I used some neon coloring, and it just kind of, it just didn't do as good of a job as the primary food coloring. The art teachers out there would love this because we're talking about primary colors, right? And so the primary colors, and I bet there's secondary and a whole bunch of other things.
yes.
But I'm going to have to let them do it. They'll have to add it to the Facebook page, okay? They'll have to add to the Facebook page some ideas about colors, and maybe they even have a color activity. I don't know.
Maybe they do.
I'm going to let them be creative. All right, so here we're going to do this. And we're going to take the food coloring, and we are going to put the food coloring inside the milk. Weird, I know.
Dr. Campbell, that is so cool.
I know. This is exciting. And then I'm going to use red, blue, and green.
Oh.
So all the art teachers out there, you already know, I bet, what's going to happen. I just know you know because you are all about understanding about these colors. And I'm talking about colors a lot, but it's really about bubbles, okay? But this is the first thing to do. So then you're going to take your detergent and a Q-tip, not too much, and then you're going to put it just inside.
Oh my gosh, Dr. Campbell.
And
That's so fun.
It's so much fun. I can't stand it. It's so much fun. And then look, and this is really not the experiment, guys, but how much fun is this, right?
No.
And so we're playing with color, and I love it. But then the coolest thing I found out, and I found this out from the physics girl on physics girl on PBS.
PBS. I love PBS. And the physics
PBS
girl.
is great. The physics girl is phenomenal. Oops. I changed the word a little. She is phenomenal. Okay, so what she said to do, and I'm not sure if you're going to be able to see this as much on here, but she just likes, I saw one, and I don't know if you can see, but I've got to get to a certain angle, and the bubbles actually pop up on top and roll on top. It is the most exciting thing ever. Not only do you have color, but you have this odd bubble situation happening. And so I'm trying to get it, look, and you know what I also figured out, Miss Young, is that if I took my Q-tip, because I just like to experiment, you know, I like science, you know.
Who doesn't like science?
I know,
mean,
I love it.
Seriously,
Science,
it's all
man,
around.
so
all
good.
around us.
So these colors are phenomenal. Oh, they kind of look like my lab coat. All right, so what I want to show you though is I played around with it and got a little more dish detergent on it, and if you just gently, the angle's hard to get it, but if you I saw there's some more. I saw some more.
Oh yes.
So I have a regular bubble here, like the ones you blew, and you'll see those. But then there's these crazy bubbles that almost look like, and the physics girl says this, like bowling balls on top of milk.
Wow.
And the color, it is really awesome. And the reason that you do this, you just flick it. And you've got to watch the video. It's called Physics Girl Anti-Bubbles. It's phenomenal. But it is so good. And there's also a slow motion video that we're going to share the link. There's a slow motion video. I'm going to come back around.
Come back around, Dr. Campbell.
That's right. And there's a slow motion video that we would like to share with you too about making bubbles. And it actually shows how to make a large bubble, huge bubble.
Oh.
And it also has some really good music because we watched it, remember?
Yeah.
It's really cool.
Yeah.
So let's go to the slide that says the question we had before.
Question.
That's going to help us with the phenomenon. How are a bubble and a balloon alike?
Something to think about.
Okay, so we know that there are layers of things,
Yes.
right?
Uh-huh.
Okay, so if we could leave the question and come back to the live at the table, there are layers of things, and we have brought some, I got food coloring on me. It's okay. It'll come off. Don't get worried at home. But we have brought some balloons, and we did not blow them up, but I'm going to blow one up just a little bit.
Okay.
Do you want to blow one up too?
Sure, purple.
Because this is also,
Yeah.
this is also kind of fun. Make you smile.
Okay.
Okay, so this resembles the balloon that was on the slide. Now, we talked a little bit about molecules, you know, and we have to have models, guys. When there's something we can't really see, now we've seen the bubbles, we've seen the solution, but deeper inside that liquid, and also Miss Young's liquid, let's pull it over here so we've got them side by side. There are little tiny
Minuscule.
minuscule molecules. Molecules. I wonder where that word came from. They're tiny. So if you look at this, if you will envision that this is one of the tiniest we can't see, okay, and it's inside there, or it could even be one of our bubbles. I mean, we can think of both ways, tiny or whatever. It could be either way. But this is going to represent the bubble. Outside there is a layer, and inside there is stuff. What's the stuff inside, Miss Young? What's the stuff inside?
It might be those molecules. I don't know.
It is air molecules. Stop.
Air molecules.
Air molecules. There's a slide. If you'll put that up just really quickly. Should be the next slide up. Keep going. Perfect. If you will look at this picture, and this is actually from the Physics Girl on PBS. But it is showing you the layer of either the bubble or the molecule, whatever you want to look at, but this is more like the bubble. And it has those little white dots inside that picture. What do you think those white dots are? You said it a minute ago, Miss Young.
Probably the molecules.
It is the air molecules. That's so good. And then look, do you see a push and a pull on that picture?
I do. Like the arrows. And
What?
Yeah.
There's a push and a pull.
That's weird.
That is really weird. And it's like physics. It's a push and a pull. It's work.
Yeah.
So in the tiny bubbles and in the bubbles and in molecules, there's always work. But let's think about bubbles specifically. Inside that bubble, there's tiny air molecules. The layer on the outside is holding it, but then there's stuff on the outside of that layer pushing it too.
Wow.
I know. I just can't. I know. Let's just let her balloon out.
Let her balloon
Are
out.
you ready? we have a book to explain this phenomenon a little more deeply, and we have a slideshow. But this book is perfect. Bubbles float, bubbles pop. Miss Young, do we want to share? Do we want to?
We're gonna partner read.
Move on in. We're gonna partner read.
We're gonna
I love
partner
it.
read.
I love it. Okay, ready, set, go.
Ready, set, go.
Go ahead to the slide where the girl's blowing
Mm-hmm.
with the background. Perfect.
All right. With a puff of air, bubbles appear like magic. Shimmering, they float through the sunlight. Do you know how bubbles are made?
Next, I love it. Balloons.
Every bubble is a round pocket of gas. Like balloons, bubbles trap gas within a thin skin.
Like the bubbles on the outside of the thin skin. I
we,
love
We
that.
provided a model to show what we're
yes,
doing.
Yes, I love it.
Bubbles form in cold or hot liquids. In a cold glass of soda, bubbles stick to a cherry. Wow. In boiling water, bubbles sparkle like diamonds. Girl's best friend. Pop. When a bubble's skin gets too thin, the bubble breaks.
Oh, and that's kind of what happened when you were blowing your bubbles.
Yes.
Oh my goodness. Okay, I love it.
The gas inside the bubble escapes into the air. Dry hands, wind, and sharp objects cause them to pop. Bubbles always form in the same shape, a sphere. Bringing some geometry and math in.
I love it.
A sphere is perfectly round. Why are bubbles spheres? Why aren't they like ovals or cubes? A sphere is a strong shape. For its size, a sphere can hold a large amount of gas.
Oh my goodness.
You just saw that, didn't you?
I do. The bubbles. I love it.
Looks like Nemo up there.
It does look like Nemo.
You can make bubbles by blowing air into a liquid, but these bubbles quickly pop. You might see air bubbles in a fish tank. Air bubbles add oxygen to the water.
Oh, he's taking a bath. Can I read a little bit too?
I
Do you
would
think?
love
Is that
for
okay?
you to read.
I am excited. This book is so good, and you know our librarian donated this book for today's segment, and I'm so happy.
Shout out to Elizabeth Shepard.
That's right, Miss Shepard at Discover School. Way to go. Soap lets you blow bubbles that are less likely to break. Kind of like the soap
Yes.
and the sugar.
I know.
Because their soapy skin stretches, soap bubbles last longer than air bubbles. Oh, I love this picture with a hand.
Yeah.
Can you touch a soap bubble? To hold a soap bubble, wet your hands with the soap solution. There's our word. Solution. Then gently catch a bubble with your hand.
And it's really important to wash your hands.
Yes, and this picture is why we are chewing gum today. Not to be rude.
Not to be rude.
Not to be rude. Have you blown a bubble with soft, gooey bubble gum? As you blow in air, the gum stretches and the bubble grows. The world's largest bubblegum bubble, which I cannot even imagine, was almost 2 feet. A little conversion there for math is a 0.6 or 6/10 of a meter across. What will happen when the gum gets stretched too thin? Pop.
Pop.
And we were afraid of that today, that it would be all over our faces, and we couldn't do the segment, but we handled it just fine. And I'll read these two, and do you want to finish it out?
I'd love to.
That's wonderful. Nature is full of bubbles. They sparkle in streams. They froth and foam at the beach, one of my favorite places. Look for bubbles wherever there is water.
Is water.
Okay.
Nice.
Or milk.
Or milk.
And milk has water in it. So,
Some gas bubbles grow deep in the earth. They push through pools of mud. Ooh. Finally, mud bubbles burst with a squishy plop. Yuck. Now the air stinks.
oh, it's gases coming out of the middle of the earth. Gross.
Ooh.
But also cool.
Look at this picture.
Oh, this is crazy.
A spittlebug.
A spittlebug.
Surrounds itself with bubbles, hiding in bubbly foam. A young spittlebug is protected from its enemies.
And if you look at this page on the left,
yes.
I wonder if there's one in there too.
I know.
You know, and this is like looking at what he might create. I don't know. I just thought that was really interesting.
Really awesome.
Kind of camouflage.
It is. A polar bear swims underwater. As it swims, it exhales or breathes out bubbles of air. In a tub or pool, you can blow bubbles too. Just breathe out underwater.
I love that polar bear picture. Oh, this is beautiful.
Beautiful. Every bubble is a tiny world. Look closely. Who is looking back from the bubble? Oh. And look here, Dr. Campbell.
Oh, good. This is bringing us back
Some
to
of
our
my
making meaning.
favorite part of a book. The glossary, read more, internet sites.
Oh, and it says right there, www.facttown.com is where they got this information, and it even gives us some extra things they might read.
Exactly.
I love it. So if we could go back to our live feed off of the PowerPoint, we have a few words of that we want to share and talk about. We have a few words. We've already shown the solution. We've already shown that one, and we've made some solutions, right? And so we know kind of what that looks like. It was in the book, kind of helped us out. And then we have this positive and negative charges, and we didn't really talk a whole lot about that. That's something for you to really think about, though. Positive and negative charges also exist in bubbles, and that's where the physics comes in.
Yeah.
It's really interesting. And if you go to the Physics Girl on PBS, I keep shouting out PBS Physics Girl because I didn't even know it existed until we started working on the segment, and I'm just excited. And then there's a push and pull. We saw that in the slide with the molecules, right?
Right.
And then that's the force.
The force, yeah, that's a little
May the
physics.
force be with you.
May the force be with you.
It made some sixth graders giggle, I bet.
Uh-huh.
And then this word, liquid, kind of makes me also think about this word, solution. So there's a little more deepness into it as you get older and think about it and dig into it, but you'll be able to see how they're connected.
Exactly.
And so we had our bubbles, we had our balloons, and this balloon was the skin on the outside of like the bubble. We had bubbles that looked like bowling balls on top of the milk solution, and the playing with color, which was wonderful. And now we want to look at maybe just wrapping it up. What do you think?
Dr. Campbell, I've had such a good time today.
It has been so good.
So fun to
I know.
be here and share.
Yes, and to be with you guys as well. We are so excited to be able to share some of this science with you all. And we do have some resources and some
Yes, we
things
do.
that they can shout out to.
Exactly.
Right, so if we'll look at the last two slides,
Last two slides.
and then we'll say, we'll be done today.
Exactly.
So we're going to give a thank you all to PBS Physics Girl,
Beyond Slow Motion.
which is the Big Bubble video, TSIN, and the TDOE.
And Murfreesboro City Schools at Home.
That's right, and that's what we're doing right now, and Discovery School. That's great. Move to the last slide. And anytime you are working with bubbles and color, if you want to post on Twitter at MCS Communicates.
At the TSIN and at the TNEDU.
And on Facebook, Miss Young, what we got 3 different places we can post.
Murfreesboro City Schools, at the TSIN, and at TNEDU.
Guys, you are great. We are so excited to be here. We love teaching and we miss you all. We hope that you have a great day and have a good time at home. Miss Young, it's just so good to
It makes
be able-
somebody smile today.
Yeah.
Makes somebody smile today.
I love it. Make somebody smile today.